First example, we're going to look at a, a program that has its function definitions first. So let's take it step by step and go through absolutely everything that is happening here in this example. First and foremost, again, the function definitions are going first. So what this suggests is after our includes and before our main, that's where we're going to see our function definitions. Now, the reason we would do that is so that we have structurally located at the very top everything the next developer in the chain is going to need to know to kind of evaluate what sort of functionality it is that we are providing to this particular program. So here we have functions with names that are perfectly derivative that I hope are easy to follow along with. We have a function that does addition. We have a function that does subtraction, a multiplication, and a division. Now, we'll get into the rest of the function definitions here in just a second, so don't jump the gun. You'll notice here it is on line 25 and below. That's where we have main. So it's different. Certainly, it's different than what you've seen already. We are taking functionality out of main and we are shifting it elsewhere. The benefit to that is, though, that when we shift it elsewhere, when we make a change to, this is a small piece of a program, 46 lines. So it's not that big a deal, right? But it's extensible in that if we were to make a change to this one small, 4-line chunk of code, what happens if we do this over and over and over and over again over the course of a very long program? What happens if it just so happens that this little 4-line piece of code is something that's tremendously important to something that we're going to do? We are consistently adding things together here. Well, as a developer, the benefit here to function programming, like we see it here, is this little module has one place where the actual structure of the code is located. So the sequence selection and the repetition, all of that is here in, well, in this case, 4 lines of code. So that means if we have to make a change here, if a variable name needs to change for whatever reason, if we have to change a formula for distance because, now in our manufacturing facility, instead of, a tenth of a micron of, of variability, we have new equipment that gives us 100th of a micron of variability. So that means we have to go through there and change the math. We can do that in one place. And after making that change in one place, it is automatically assured that in all of the variable places, the hundreds or thousands of locations over the code that you call to this one function, it's guaranteed that that one little change is already pushed through and cycled through the rest of your code. So modular programming is great that way because it saves you a ton of time. So here we'll just take a look here at addition. The subtraction, multiplication, and division follow exactly the same suit, potentially with different return types and slightly different definitions, but I think that you'll, get along. So the first and foremost thing is right here. This is the prototype, the function rather, return type. So int here suggests that when we return something here on line number 7, that return type is going to be an int. Down here with division, you'll notice that I'm returning a double because the resultant of integer division is going to be floating point number. So I could have made this a float or a double. We have the name next of our function. One thing before we continue on, you'll notice here we do not have a void type return. A void function does not make a return. So we'll see those in subsequent examples, but not here in the first one. So here we receive two variables. We've got int variable 1, so this is prepping the function to be able to receive an integer type variable, and here the name, we are going to call it variable 1. Here our second received parameter is going to be an integer type. This is going to be of named rather variable 2. And here inside of my function, I'm just returning the result of variable 1 plus variable 2. And that's it. So variable 1 is here, and that is whatever is sent from main to, or from potentially a different function, but in this case it's from main. So when we get our two integers, I'm going to pass to that's down here on line 35, I'm going to pass to the function addition two things, 1 and 2. So you'll notice that here in main, my integer values are called, the variables rather, are 1 and 2. 1 and 2. But what happens here in my function? I have variable 1 and variable 2. They are not the same. That's actually okay. The program does not care what a variable name is in the calling function. It does not care what the variable name is in the called function. All it cares about is what's happening here at runtime when we've made this call. So that's right here on line 36. At the time we make this call, it cares about what parameters are being passed and what we call them in the receiving function. So that is right here. So we can refer to them as variable 1 and variable 2 here inside of our function. And you'll notice here on line 36, again, I have the result of a call to my addition function is simply outputted here in my cout statement. No problem. It's the same way if we would have done, and you have by now been doing math in a cout statement for the resultant of something, and that works just fine. It works just fine with a function call here as well. The subtraction, multiplication, and division functions work in exactly the same way. They are calling to integer functions, with the exception of the double division, so the division function, which has a return type of double. So I'm going to enter in two integers here. I'm going to say 5 and 10. So here are my results from that. So first we call to addition. 5 plus 10 is 15. Fantastic. This is working so far. Next we go to subtraction. You'll notice it gives us a negative number. That's perfectly okay. Positive and negative numbers are inside of the range of integer type variables. Everything is working the way we expect it to. I can use an integer here because 5 times 10 is 50. And here, the last line of my output with a double, because I'm doing integer division, I need floating point precision in my answer. And there it goes. The other thing I didn't point out here, but I will point out now, these lines down here, just as a little bit of a difference, in lines 36 through 38, I simply outputted the return of the calling of those functions. So here, which would be right here, what we saw was the output of the call to addition that returns a value here. You can also assign the returned value to another variable. So right down here, and I'll admit to you, I did not name them particularly well. I have a double called 3 because I have integers 1 and 2. I just continued on with that kind of general lazy theme. And here on line 40, I have 3 equals a call to division. So that's a call to this function called division. And I've passed it 1 and 2. So whereas I'm just showing you the different ways to be able to do this, there is no, you know, there is no actual difference in the way that this is outputted. It's simply a difference in the way that, the code is being run. Here, the resultant of a call to a function is simply put in the output window and then, you know, done away with. There is no remaining way for us to be able to get back to the result of addition, the result of subtraction, the result of multiplication. But here we can actually, because I've saved the result of a function call to another variable. Your mileage will vary on which one of these two you have to do. Can you simply make a function call, or do you need to make a function call and make sure that that is stored someplace in a variable for later on? It depends.